everybody, and I'd like to welcome you to part 2 of our two-part series talking about evaluation concepts as presented by the Office of Community-Based Research at St. Mary's University. In this video, we're mainly going to concentrate on quantitative, although we will do some presentation on qualitative approaches toward data collection, data analysis, and data reporting. We'll spend a little bit of time also on things like instrument development and considerations related to validity and reliability. Our goal in the second part is really to kind of introduce these concepts. We will not spend really any time talking about how to run certain kinds of analyses, and really the finer points will, such as statistical assumptions and these kinds of things are really not going to be talked about in this video. Instead, as mentioned before, our goal is simply to get you kind of thinking about what goes into the entire process of imagining which variables need to be considered to how are you going to then sample and what kind of instruments are going to be used to generate the data, what types of analyses, not how to run them, but which types of analyses would be appropriate, and then what happens when there's missing data, and which kinds of statistical software are available in order to actually run those analyses. So when you're done, hopefully you'll at least have some direction, and you'll have some ideas about whether that needs to be an in-house or out-of-house process. So again, welcome to this second video, and without further ado, let's get started. When it comes to evaluation, much like research, the main things that we're interested in are our ability to explain, predict, and control. And that might sound a little bit like a laboratory process as opposed to something that's very applied, which is often the case, right, with nonprofits and their evaluation. But at the end of the day, it's still the same thing. What we want to do is we want to understand relationships. Because if we can understand and explain why we're getting the kinds of outcomes that we're getting, if we can make predictions about what types of outcomes we could get if we manipulate certain features of the activities, then theoretically we can influence the process such that we change the system in a way that we can reliably get better results. And ultimately what you're talking about then is, and this is kind of a buzzword in the field, right, is data-informed practice. And that gives not only the external funders more confidence in giving you money because they feel as though the decisions are grounded in something other than best intentions and goodwill, it also should inspire confidence for those who are actually on the ground providing the services, because at that point, you're not just sort of going exclusively on the vision or kind of wishful thinking of folks in charge. You actually have something to work with that shows if we do X, it's more likely that Y will occur. So as we make our way through the remainder of the video, those are the things that we're mainly thinking about: explaining, predicting, and controlling. So next up, we're going to talk a little bit about validity and then reliability. Definition. So what all then goes into establishing construct validity? And so there are a few subtypes that we'd like to concentrate on. One of them is criterion-related. Now, as you recall from a minute ago when we were talking about the importance of explaining variance, we talked about whether or not you could make predictions and see those kinds of relationships. So what criterion-related validity comes down to is really predictive or concurrent forms. Predictive meaning if you know ahead of time the value on one, let's call it an independent variable, then you have an idea of what the value on a future criterion will be, like a dependent variable that is yet to happen. Concurrent validity would mean, as the name might suggest, that it's not something in the future, but something that's going on right now. And so through the evaluation, what you're ultimately trying to do in this sense is be able to say, if we know that the folks in our program have these characteristics, when subjected to our program, it's likely then that they will show changes in some kind of behavioral criterion. Okay? Content validity is another form. Now with content validity, what we're ultimately talking about is whether, say, the items on a test reflect the constructs that they're supposed to be measuring. And so in my classes, I would oftentimes talk about a history exam that only has, addition and subtraction and multiplication, division. That would be low content validity, because what it's supposed to be measuring has nothing to do with what the items actually are that are on the exam. Okay, then we can look at convergent and discriminant validity. And so in that case, what we're talking about is whether or not the scores on a particular instrument are either going to look very similar to other related constructs that theoretically they should be related to, and then sufficiently different as to not be redundant and certainly not associated with other instruments with which they should not have a relationship. And so, a lot of what you're really looking at, in practical sense as a nonprofit, and we'll get to this when it comes to the items within an instrument later, but you also don't want to have overkill. You don't want to get to a point where people have evaluation fatigue. And that's either as the researcher or the evaluator who is administering these, or the person or persons that are taking them, because you want your data to be valid, which means then that you want the folks involved to be effortful in what they're doing. The last type of validity that we're going to talk about for the time being is what we call ecological validity. And for us, this is really at the heart and soul of what a good evaluation would do. Okay, so in a more clinical sense, you might think of a problem with ecological validity being as follows. And that is that a developmental psychologist is interested in the dyad of parent and child. And so they set up a very controlled situation. The parent and the child come up to a university campus. They're seen to be interacting. They collect their data and they make decisions. When they go home, that interaction and the nature of it might be very, very different, right? Because of the setting and all the different contextual information that goes into influencing behavior. So ecological validity in the evaluation sense means that when the evaluation is going on, we're really getting a good picture into what it would be like in its most natural state. To the extent that we deviate from that, we're costing validity, going back to that parent construct of construct validity. So in the next part, we're going to talk a little bit then about reliability of scores. When it comes to reliability, what you're really trying to get is whether or not under the same conditions you would find similar estimates of a given trait, right? So if we think about soil sampling, if you were going to go out into the front of the CBR office building out there and look for, nitrogen in the soil, you would expect that if you took 10 samples from the same area on the same day, roughly at the same time, that the parts of nitrogen in the soil per, million would basically be very similar each time that you took those samples. So in other words, you could trust the results that you were getting back. And you can see now how you couldn't be valid without being reliable, because if you're getting information that is inconsistent, then it can't be measuring what it's supposed to be measuring, given that everything else has remained the same. Okay, so then when we think about the types of reliability, or at least methods of estimating the reliability of scores, we talk about test retest. So this might be a situation where in an academic scenario, a person takes an exam like the SAT, and maybe they wait a day, they take it again. Well, those scores should be correlated, right? If you took a number of people that did this twice. Now, on the other hand, if you are worried, okay, so if they took the exact same set of questions in the SAT from the first one to the second one, is it at least possible that they learned something, right? From having taken the test, even if they didn't go home and look up answers or anything like this, just the process of having been tested in that format with those same items twice could in fact influence the scores. So one way to deal with that is what they call alternate forms reliability, which means then that if you took the SAT once, you could come back and take the SAT again, and that second time would be a different set of items. But you would still expect, if you had 100 people doing this, that the scores on the first one would correlate with scores on the second one. Another way of trying to establish a sense of reliability, or at least get an idea of how the scores are how trustworthy they are, has to do with internal consistency. And that would be the relationships within one single administration, the intercorrelations within the particular instrument. To the extent that they're high, that people that got a question right also got other ones right, that would be internal consistency, and it would be another means of not having to worry about the learning associated with test retest. So we'd like to consider qualitative data analysis for a minute. Unfortunately, qualitative data analysis gets a bad name, I think, unfairly. And a little bit of history for me is that, as I mentioned earlier, I have a degree with an emphasis in quantitative methods, and it was not uncommon for those around me at that time to make fun of qualitative data analysis because they would say it was just fluff, right? And it was make-believe, and it wasn't to be taken seriously. And the only people who would do it were people who couldn't do quantitative analysis. Yet, when I would go to academic conferences, and there were friends and other people that I admired who did qualitative analyses, they would tell me I was one of those. And by one of those, they meant a quant person, and they basically equated quantitative methods with racism and with reductionism, and that was not good. At conclusion of that, and kind of reflecting, it's my belief that both are basically trying to do the same thing. They're both trying to understand relationships. The qualitative research, on average, tends to be deeper and richer, and in many ways even broader than the quantitative. Broader within a context, but it's sometimes less, or oftentimes less, generalizable. And you really have to count on the person being the instrument in those cases. That's not all the time untrue for quantitative either. You still have a set of values that you're emanating from. You still have a set of methods that you have pitched to yourself and others as being better than other methods. There's still decisions to be made, even in quantitative data analysis, and especially as you get to the higher levels. But with qualitative, what you really want to do, given the suspect nature in many people's eyes, is to build a case for trustworthiness, to really explain to folks what your process was and how you were able to compartmentalize you yourself, you as the instrument in this process. Now, there are many different ways of doing qualitative research or evaluation in our case. Two of the main ones, of course, being grounded theory and critical theory. One, the grounded theory approach says that you should go in as a blank slate, let all themes emerge organically from the data. And the critical theory says we already know certain things about power relationships, and a failure to immediately and always take those into consideration is irresponsible and leads to inaccuracies and omissions. I'm not going to pitch either one of those. I think a blend of those two things kind of makes the most sense. If pushed, I would probably lean more towards the critical side, but I don't think that it would be worth pledging such strong allegiance to either of them that you didn't take what the other one has and use it to your advantage. I'd like to say also that you'll probably want to consider multiple data sources when you're converging upon a common reality. You'll want to consider the idea of triangulation in that sense. And you'll also want to have a very systematic way of doing your coding. One of the things that I've seen, especially in service learning scenarios, is the idea of just cherry picking anecdotes. And that's kind of what gets qualitative a bad name. That it's, well, I went through and I saw 4 inspiring quotes, and so that's what I'm counting now as my qualitative study or my qualitative evaluation, and I hope the funder likes them. And at one time, that was a little bit easier to get away with than it has become recently. So you'll really want to dig down deeper into the different ways that data are systematically coded, and also consider some of the software packages that are out there. And then finally, I would like to pitch the idea of member checking, which, as we had mentioned a little bit in the first video, you'll want to go back to the people from whom you collected your data and just make sure that the way you were interpreting how they saw things is consistent with what they intended. That doesn't mean you have to draw the same conclusions, but at least you should be representing their reality accurately. As mentioned before, quantitative data analysis is considered by many to be superior to qualitative. And in some ways, it almost doesn't matter whether that's true or not, right? Because when you think back to your stakeholder map, part of what you were doing was considering how people thought of success. What does success look like to them? And so even if we all kind of came to a friendly agreement that neither qualitative nor quantitative is superior, in many cases a mixed methods approach combining the two gets you to where you want to be, that's well and good. But if you're not having an impact on your audience, whether that's community members, whether that's funders, whether it's people within your organization, that almost doesn't matter, right? So what we would ordinarily advertise as a good strategy is to do what's right and do a little bit more just to be able to keep on the good side of the people that you need to, you know, to humor, I guess, for lack of a better way of saying it. There are certain things that people need to hear, and if it has to be expressed in quantitative terms, just like at times when the anecdotes are the way to go, and a qualitative approach, even if you say, look, our evaluation is far more rigorous than this, we can do a far better job, it might not matter if that isn't what folks are prepared to hear. But there's still some things to consider on the quantitative side. One of them is descriptive versus inferential statistical scenarios. So are you collecting the data just to describe the folks from whom the data have been collected? And unlike research, evaluation is oftentimes that way. We're not trying to guess about some unknowable population, and we're treating our people in our program as a sample. We're simply trying to describe how the folks that we impacted were impacted. And so, you know, a lot of what we're going to talk about today is more inferential based. It's kind of assuming that you would say, well, you know, we were able to help 150 people, but these 150 people represent a broader population of folks who could be helped in the future, or could be helped if this program were broadened to include Phoenix and St. Louis or places like this. If you're not trying to do that, then the descriptive is the way to go. And I would definitely make use of a lot of nice visual illustration type stuff with the descriptives to be able to make that case. Another thing is that quantitative data analysis, especially in the inferential side, right, considers more as more. And so what I mean by that is the bigger the sample size, the more compelling the case. Now, statistical testing takes into consideration sample size when it comes to testing the null hypothesis. But even at that, like, if you're trying to make a case, the belief is the more data points that you have, the more believable. For me, I question some of those things, but again, that might be a bit more advanced than what we're trying to get at here. And it also might be irrelevant to the people that you're trying to convince. Another thing is the need for person level data. And what I mean by that is some folks who do the evaluations for you will provide you only with aggregate information, not at the individual person level. And the reason that aggregate is not as good as person level is because it doesn't allow you to run some of the more advanced analyses. You can't really see relationships and correlations and those kinds of things unless you have person level data. So we always strongly encourage folks, especially if they're doing their own data collection or getting it from one of those secondary sources and we're not doing it, to make a case for getting the person level data. And we understand that that can be difficult given the desire for anonymity, confidentiality, and what's contained in data sharing agreements, but just understand what is being lost if you settle for aggregate data. And then finally, sometimes the more sophisticated data analysis play better to funders because they, I guess, think that you're more expert or something. But really, what you want to do is to calibrate the types of analyses that you run to the audience that you're trying to reach. Because if they're not hearing it, then ultimately, again, it's not going to matter. Oftentimes, when folks come to us looking for assistance, the main thing that they're interested in is we need to find a metric. And by that they mean we don't know which instruments we can administer to our community members that will be able to show that we're influencing their lives in some way. And when we alluded to this earlier, much of the time, if you have mission to metric alignment, the instrument will almost just jump out and grab you and say, pick me, because the conceptualization is so strong that it becomes just obvious what needs to be done from an instrumentation standpoint. But basically, even then, sometimes folks are not as familiar with the literature as they could be, and so it's helpful to get a fresh set of eyes and say, hey, you're in this area, can you help me out? So we appreciate that. But we can also divide the instruments into two different types. One is your homemade instrument, and the other is an existing instrument. The homemade instruments, have pros and cons. I think maybe in some ways both the pros and the cons tend to be exaggerated a little bit. People are reluctant, let's go to the con side, to just try their hand at creating an instrument. Now, the pro is if you have the courage, right, in the background to be able to do this, your instrument will probably be very specifically targeted at that which you want to influence. On the other hand, going back to the con, folks sometimes have an exaggerated sense of ability, and they believe anybody can create an instrument. Anybody, it's just a survey, I'll just put it together. And we've seen, a lot of instruments that have violated pretty much every best practice recommendation known to humankind. And so we worry because we don't know what conclusions are going to be drawn and what decisions will be made policy-wise, funding-wise, and so forth from instruments that have been poorly conceived. In the purest sense, what you'd do is you'd have like a concept map and you'd talk about the different constructs that needed to be measured, and then you could pilot test and you could run factor analysis and you could do all these things. I mean, entire dissertations are written about creating a single instrument. Research agendas are carried about trying to figure out the validity of scores with the instrument under different conditions. This is no minor task, but if done correctly, could actually bring you to a place that's superior to just about any existing instrument that might be out there. Okay, so now let's switch over to the existing instruments. The benefit is there's already some information about this instrument, hopefully when used with populations like your own. Now, I'm going to say that one of the bigger errors that people make when they talk about instrumentation is what is the reliability or the validity of the instrument. But there is no such thing, right? Those things characterize scores. And if you think about it for a minute, that kind of makes sense. So if you say, here's an instrument that is typically being used with 35-year-old, kind of early to mid-career professionals, now let's give it to first graders. The instrument itself didn't change, but how much stock you can put in the scores probably did. Or, let's just say, if it were written in English and you had a monolingual Spanish person take it, the instrument didn't change. But the relationship between the person and the instrument did when used with that different population, and so the scores will mean something different, right? So even if you use existing instruments, it's good that there might be information about them, but you got to make sure that that information about them is relevant to what it is that you're trying to accomplish. And then finally, we would say that you need to recall the ideas of the logic model and the theory of change, because a good way to minimize that fatigue of instrumentation is to make sure that there's very little redundancy and that the instruments are serving a purpose to respond to the evaluable questions. When it comes to survey design, typically less is more, but to a point. One of the things that we hear a lot from the nonprofits with whom we work is that they're worried about the fatigue, they're worried about being too burdensome to the community members or whoever it is that they're trying to collect data from. And so they say, well, let's make this as small, as concise as possible. I don't know about as possible as the best recommendation, but as practical as we can and still be useful. If you recall, right, we talked a little bit about reliability earlier, and the only way to really establish reliability is to have multiple measurements of the same thing. And so what happens is if the survey is just made short for the sake of being short, you miss out on the ability to really assess how those items are functioning because they don't really get compared to anything else. If there are multiple items, they can be compared to each other. So yeah, I think that the idea here is just that, it's true that we want to be able to keep things reasonable in terms of the amount of labor that we're asking of folks, but we can't lose out on data altogether. I mean, think about the other end of the continuum. If we ask as much as possible, if we don't need it, we can throw it out. But if we never ask, if we never collect those data, they're gone. And if you think about evaluation as being a snapshot of a point in time, we're not ever going to be able to get those data back. So balance is the key. I would agree that we need to ask as few as we can and still get the quality of data that makes the evaluation worthwhile. Now, in order to do that, there are a few things to take into consideration. The main thing, as we had alluded to before, was this idea of a construct map, which means then that you map out all of the different dimensions that you're wanting to measure someone on, and then you can write items to those. That'll help keep track of whether you've completely saturated the construct or whether there's still more information that needs to be obtained in order to cover everything. In addition to that, you can also do some little tricks to make it more likely that you'll get quality data throughout your survey. So for example, the boring questions like demographics and all of this sort of thing, you can put at the end. It's less likely that somebody is just going to circle anything for something like race or gender as an attitudinal question. So by the time that they've become fatigued and care less, I guess, than they did at the beginning, then they can answer questions that are very easy for them, not very taxing, in which it's unlikely that they're going to give the wrong response. Another question that we get sometimes has to do with scaling and midpoints. So traditionally, right, if it's an attitudinal scale, most of us are familiar with Likert, so like strongly agree, strongly disagree. And those are okay, and then people ask, what should I put in the middle? And usually what you want to try to achieve is a balance, right? So you don't want to have 4 questions saying that you like the product and only 1 saying that you didn't like the product, because that's kind of stacking the deck. Because then you can take credit for 80% of the response options. But to give people an out in the middle and say, I actually genuinely feel in the middle of the scale is usually the best, unless you want to get them off the fence. If it's absolutely necessary, like in a vote scenario, yes or no, maybe undecided, possibly in some cases, but then you not want to use that middle point. And then when you get your data, it's important to clean the data that you have to make sure that you're honestly and accurately representing the constructs. And so you'll want to look for patterns that suggest that respondents didn't understand a question, or didn't want to respond honestly, or take out the cases where people have made patterns like all on the right, all on the left, a diagonal. So there are a lot of things that go into then constructing the survey and then cleaning the data that you get from the survey. And we at CVR can obviously help you with that when the time comes to do so. Another thing that we hear about quite frequently are concerns about sample size. And sample size is an interesting thing, right? Because as we talked before about quantitative research in particular, there's this emphasis on more being more. And, to an extent, there's some truth to that, right? But the biggest thing is, at least theoretically, the representativeness of the sample. If you're dealing with inferential statistics, the whole point of a sample is that the information that you're gleaning from it applies at the population level. So theoretically, if everybody were identical, you'd only need 1 person in your sample to absolutely perfectly represent your population. The reason that more is more in quantitative is because it increases the likelihood of representativeness. But depending on how the sampling is done, that in the end, that may or may not actually be true, right? So selection bias and these kinds of things are equally as important as just the total volume of the people in your sample when it comes time to thinking about how good of a job you're likely to do in representing the full population. Another thing, though, to consider is how big of a population that you're wanting to make inferences about. So it could be a situation where, like I know someone, for example, one of my colleagues does research on captive beluga whales. And so using, the traditional ways of thinking about sampling error, if you have a very small number of beluga whales, it would seem as if there'd be a lot of error because you just don't have that many observations. But if you think about how many captive beluga whales there are in the world, even a small number of them, it still represents a pretty decent proportion of the total captive beluga whale population. And so, you're not necessarily in as bad of a situation as you might otherwise be. And if you use like the online calculators and these kinds of things to look at statistical power, right? So your ability to correctly reject a false null hypothesis. In other words, to be able to detect differences when they really are there. What you'll notice is that there's a very quick diminishing return scenario where really, really, really big sample sizes aren't really that much better than just sort of moderately large sample sizes. And so, you got to think about that. And you've also got to think about the types of analyses that you're going to run. If, you have a regression, which we'll talk about in a minute, you might need more observations than if you have a t-test. So these are all considerations before jumping out and spending a lot of money trying to get this really, really big sample because you think simply that more is more. When it does come time to actually draw a sample, you'll want to think about the sampling strategy that makes the most sense for your case. My students and the community partners all kind of tend to believe that the true random sample is the best way to go. And there aren't a lot of benefits with true random sampling, but there are also some, how can I say, difficulties. Not necessarily so many cons, so many like bad things about true random sampling, just some practical difficulties. But first, let's consider what true random sampling even is, right? So true random sampling includes replacement. So that means that every single draw of a person, we'll say, and it usually is the case in the evaluation sense, that person, that element, has an equal chance as every other element of getting picked. Which means then, if that person or element has already been picked, is irrelevant. So you theoretically could be asking the same person to complete, say, a questionnaire 3 times if you wanted true random sampling. Now, you know, most folks aren't going to do that, so they're going to use a variation that's not true random sampling, and they're going to say, well, it's without replacement. If you've already done it, then you don't get picked again. But even at that, you would still need a complete list of all of the possible folks who could be included in this. And you would actually have to be able to have access to them so that if their name got picked, they could complete it. So sometimes that's not possible, and sometimes it's not practical. So for example, cluster sampling, where you take, instead of the person as the element to get picked, the cluster or group becomes the element. So for example, if you were going to canvass a particular zip code, you might want to do cluster sampling by block, where basically you'd have one block and everybody that lives in that block would be asked to participate, and then people in the neighboring blocks would not necessarily be asked to participate. They might, I mean, if their block also got picked, but you would completely cover that one block, and that would be the unit that gets picked. The advantage, in this case, if you're canvassing a neighborhood or a zip code, seems very obvious, right? Because it saves time and resources because you hit all the folks at once. You could sample even just like a classroom instead of across the grade, each individual student having an equal chance of getting picked. On the other hand, and we'll talk about multi-level modeling solutions to this later, but it's usually the case that when you pick by clusters, the folks within clusters have more in common than they do with people outside of those clusters. And so the sampling then takes a little bit of a hit unless somehow you're accounting for that, because it gets passed off as being equally as representative when in fact there could be kind of like a shared error variance, things in common that aren't being modeled, that aren't being taken into consideration. Other ways of doing the sampling could be stratified, for example, where basically you say we're going to take this many folks who identify as white, or this many folks who self-identify as Hispanic or Latinx. So we're gonna look at proportions, and we're gonna say, and it could be proportionate and disproportionate. It's another more advanced concept we can help with. But basically, we're targeting those groups, and we're going to sample them at different than equal proportions, right? And so it's not, you're getting picked within your stratum instead of across everybody, as would be the case in random sampling. There's also various forms of convenience sampling, snowball and chain referral and these ones. And these tend to be very common because they're easier, and they tend to be able to get a bigger sample size when you don't have that full list of everybody who could be sampled, and especially if it's a small group but somewhat cohesive group, so that if people know each other, then they can say, hey, I know someone else who's got this very specific demographic intersectionality, if you will. I'll pass it along, and maybe there's even like a message board or a church or a community group, and that's how you can access a lot of people. Once again, we will help walk you through which sampling strategy tends to produce the adequate power and meets with the practical considerations. At this point, we're going to turn to looking at different types of statistical tests that you could use to try to identify relationships in your data. The first two are the t-test and the analysis of variance, or Anova. Within t-test, there's one sample t-test, paired samples t-test, and independent samples t-test. The one sample t-test would ordinarily be used if you already kind of have like a benchmark mean and you want to compare a group that participated in a program against that mean. So for example, you might have a national norm or something like this. The paired and or dependent samples t-test would basically be when you have multiple measurement points, like a pre-post test. That's also very common with nonprofits. And then your independent samples t-test has to do with having two different groups, like an experimental and control. The Anovas that we're going to talk about are just simply extensions of these t-tests. So you can have a one-way Anova, which is very similar to your independent samples t-test, except that you've got three different groups, or more. It could be 4, 5, 6, but you have more than two levels or groups. Similarly, the repeated measures Anova is like the paired samples t-test. Difference being, instead of just pre-post, you've got 3 or more measurement points. And then the factorial Anova has to do with having more than one independent variable, right? So if you had, say, gender and race, you could actually look for statistical interactions, such that the relationship between either of the independent variables and the dependent variable varied across levels of the other independent variable. So those are just options at that level of comparison, t-tests and analysis of variance. There are also many more sophisticated analyses that can be done. When you're talking about the t-test and the Anova, you're basically talking about having very specific, easily defined groups that you're trying to compare. Either an experimental and a control, or a group that took the pre-test and is now taking the post-test, or a follow-up. Some of these other ones get a little bit more information to a lot more information, but require a little bit more advanced understanding of statistics. So one of those is regression, and it can be either simple with one independent variable or multiple with more than one independent variable. And the advantage of regression, now you could theoretically do what you could do with Anova and t-test in regression, but in addition to that, you can also look at continuous independent variables. So if you think about correlations, x is correlated with y, you don't necessarily have categories of x and y. There are correlation coefficients that can handle that, but typically you're talking about continuous, not discrete. So regression helps you then make predictions using those continuous independent variables in their relationships with the continuous dependent variables. The path analysis can handle that as well as the categorical, but it actually bumps you up from a single dependent variable or an outcome that you're interested in up to multiple, right? So you can look also at whether controlling for something influence. You could do that in regression as well, but in path analysis, you can make it very visible in a diagram, say to your funder. Once we control for this, the relationship between these other two things ceases to appear. There's multi-level modeling, which in that case, we had made mention of this just on an earlier slide. You're actually, in that case, controlling for violations of the independence assumption. Now you might ask, what is the independence assumption? We said before, as our example, if you have clusters like classrooms, okay, if you go in and you say, we're going to do a new reading curriculum as an experiment in this classroom, but not that classroom. Well, the experiences of the students in those two classrooms goes beyond whatever that intervention is, because they're going to share the same teacher in one and then a different teacher in the other perhaps, or they're within a school, or they're within a state that has certain policies. So basically the language would be that those classrooms are nested within schools, which are nested within districts, which are nested within states, and so on. And you have to be able to control for that. Otherwise, you're going to have problems interpreting your data accurately. So multi-level modeling is a procedure that can help you address those kinds of problems when you've got what they would say is correlated error terms. So things that are not being controlled for statistically that may be influencing your data. There's also structural equation modeling. before, when we had talked about factor analysis as a means by which to create an instrument, what you're actually talking about with factor analysis is trying to find something that's measurable, right? Like someone's response to a questionnaire, to make inferences about things that are not readily observable. And so, you know, if somebody said, how many freckles does this person have on their face, you could actually count them very obviously. But if you said, how jealous is that person, you would have to do other things than make an estimate because it's not directly observable. Well, structural equation modeling is like path analysis in the sense that you can still model those relationships, like regression, only with multiple dependent variables. But now the constructs are latent, right? They're things that can't be seen. And you can actually do variations of that too, where you can look at the repeated measures Anova with like growth curves. And you can look at whether items in an instrument are being interpreted and reacted to similarly across groups when you do invariance testing. So there's a whole suite of possibilities that come out of the path analysis, the multi-level modeling, and the structural equation modeling that can take you to that next level of interpreting your data. Now I will emphasize, because I wanted to drive this point home earlier and I'll do it now again, this is really only possible if you have individual level data, person level data. Aggregates will not work. That's one of the reasons why it's important to get data at that level. Of course, all of these analyses are well and good as long as the people from whom you're collecting data do their part. So what I mean by that is that a lot of times, the folks will come in from these nonprofits and they'll have missing data. They'll have folks who started a program and then didn't finish, or folks who started and missed a couple administrations and then finished. And you know, if you use something like list-wise deletion, which basically means if anybody is missing data in any of those points, we throw them out, then your sample size can go down very quickly. Correspondingly, your statistical power will go down very quickly. And it could be that if the missingness is not at random, in other words, why someone is missing or the fact that they're missing is correlated with some important characteristic about them, then you could also misrepresent your data, right? So there are ways of dealing with missing data, some that are better than others. There are very simple ones that don't work quite as well, like a mean imputation. If somebody's missing, you just give them the mean. There are better ones, like regression or a multiple imputation approach, where you use very complicated statistical procedures to try to estimate what that value would have been. And then there are others that we use sometimes that are based more on hypothesis testing. So you don't actually replace the value. You just use a different approach to analyzing the data so that you can come up with a better conclusion, one that's less at risk of making a mistake in your conclusion than others. And we're certainly willing to talk more with you about that, even though it's a little bit too advanced for this video right now. Another aspect of the statistical analysis to consider is which software you're going to use to complete the analyses. Most folks have some access to Microsoft Excel, and so a lot of things that are, at least at the basic level of statistical analyses, can be accomplished through Excel. And so that's not a bad option. Plus Excel has some decent ways of being able to produce figures and graphs and tables and those kinds of things. So we don't discourage people from using Excel if the analyses that need to be run can be run through Excel. SPSS is probably the other one that people know of and use. Of course, the problem with SPSS is that it's very expensive. And so an annual license is something that could be cost prohibitive to especially a smaller nonprofit organization. And so some of us use SPSS in the Office of Community-Based Research, but less so than we used to. SPSS is also not ideal for the production of visuals either. I think Excel does a better job there. The one that we tend to more than anything else is R. R is not as user-friendly as either Excel or SPSS. It takes some getting used to. You know, there's some coding. Actually, it's all coding. But I don't think it's something that would have a really long learning curve that would be prohibitive. But I can understand where people won't necessarily be overly anxious to try to learn R to analyze their data. So the advantage, again, is that it's free. The disadvantage is it would take some learning in order to know how to run. Because when you first download R and you open it up, there isn't a spreadsheet like you see in Excel or SPSS. So already it's sort of like, well, what do I do here? And there are a whole lot of other ones sort of like this too. So for example, M+, by Mutane and Mutane. It's also an excellent software package. We use it sometimes for our structural equation modeling and factor analysis work, but it would also take a little bit of learning. And then finally, the one that is promising to replace R eventually is Python. I personally am not as versed in Python as I am in R, although I'm taking steps in that direction. But either way, in the end, there are ways to make all of these statistical programs work for you. The question usually is just a matter of learning and also, I suppose, cost. Once all the analyses have been done, the process is not quite over yet. The main thing is to go back to the very beginning and think, why were we doing this evaluation in the first place? What were the evaluable questions? What were the points of success that each of our stakeholders were looking for? And then when it comes to writing it up, that's the direction that you have to go. And so you have to think, okay, in order for this evaluation to be considered a success, we need to be able to answer these questions about how the program is working, where the resources are going, how the different stakeholders are being affected, and where do we go from here. A point that we made earlier that we would like to emphasize again is that the community members, the authentic stakeholders, should be part of this process. They should be involved not in running code from R, but once the analyses have been done, making those interpretations. As we said before, there are a lot of critics of qualitative evaluation, qualitative research, because they say that it's not objective, that there's too much of the person in it. We, on the other hand, have made the argument that there's a lot of person in quantitative, and there's even more of a person in evaluation. The questions that are asked, the methods that are used, the way that the interpretations go, and the policy decisions that come out of the evaluation all come from people. And we can't get around that, right? And we shouldn't get around that. I mean, the evaluation isn't intended, unlike, what some people would call, the gold standard of research. Evaluation is not typically just to generate knowledge, just for the sake of generating knowledge. The evaluation is meant to give you useful feedback with real people doing real things in real settings. So interpreting and sharing the data needs to take those things into consideration. Otherwise, it just becomes kind of an academic exercise. Beyond that, there needs to be an acknowledgement of the limitations. So with any evaluation, you can't possibly cover everything that needs to be covered in order to completely capture what's going on. Unless, and this sounds almost like an irrefutable argument, but unless you've designed such a simplistic evaluation that it's the value of it is very small just from the get, right? So go into the evaluation with confidence that you've thought it through and that you recognize ahead of time and have learned throughout the process what those limitations are. And then, because you have now got this culture of evaluation at your institution, you'll be cycling through the evaluation. You can actually draw on those lessons learned to make for a more robust evaluation down the road. And then the last thing I would add is simply that the evaluation process ought to open up new questions. Based on the data that you have, new things will emerge. And you're saying, okay, we didn't take that into consideration, we missed it on this particular evaluation. How can that inform the way that we ask questions, collect data, include the stakeholders? All of those little tidbits that you learn will be immensely profitable when you go to the second iteration of the process. So in conclusion, I'd like to just sort of do a recap of where we have come from overall across the two videos, really. If you were to go back to part one, we talked a little bit about the person side, the human side of doing evaluations, and I did some self-disclosure about myself and my background, credentials, interests, the pathway of getting here. We talked about the CVR office, who you can expect to be working with, students. It won't be the same students, hopefully, for 5-10 years in a row because they graduate. New folks will come in. We talked about CREA, and we talked about that's the cultural responsive evaluation and assessment, and how it drives what we do. It frames how we think, and it's not only who we respect, but who we feel responsible toward in terms of carrying out that work. We talked about the reasons for conducting evaluations in terms of giving yourself continuous feedback, getting external funding, and by the end, being able to generate new questions in an ongoing way so you can have that continuous feedback loop and be able to improve your processes. We talked about mission to metric alignment and what that means in terms of evaluation and how important that is to being able to not just get good data through the evaluation, but make sure that your organization as a whole stays on track for what you're trying to accomplish. We talked about types of stakeholders. We distinguish between authentic and compulsory, and we also distinguish between primary and secondary. Those are the folks for whom the evaluation matters, and without them, or without considering them, you can really go off track in terms of what the evaluation should be accomplishing. We talked about logic models and theory of change, and we really emphasized that although logic models get the most attention, that theory of change is really what the most critical point of this whole thing is. Why is it that you're doing what you're doing? Why would we expect the changes to occur that we're alleging will occur? Talked about Gantt charts, evaluation calendars, keeping you on track. In both the first and the second video, we talked about how to report outcomes and remembering the audience. We talked about budgeting, and then we talked about how to get assistance from the CVR office. In the second video, we talked about the qualitative and quantitative approaches, and how although they may seem different, and certainly people have different loyalties, in the end, they're all about explaining variance. They're all about capturing that snapshot in time. We went through various aspects of the qualitative research and the quantitative research. Talked about a whole host of statistical analyses that you could run and that we'd be willing to help you run. We talked about instrumentation. We talked about survey design. We talked about sample size and statistical power, as well as sampling strategies to try to get you enough people and a representative enough sample so that you can make inferences about your population from the folks from whom you've collected data. We talked about statistical software and the better choices and how to match those to what your needs are and what your cost allows. And then finally, we talked about getting all that information back in a usable format. So hopefully through these two videos, we've inspired you to think some more about evaluation and to leave knowing that we'll always be here to help you in the future. Come see us at the Office of Community-Based Research.